For this lab, we are going to open our wordpuzzle.dat file using try-catch statement. We're going to load the search words, which are these words, into an array called needles. We can load the puzzle lines into an array called haystack. We're going to load our 6 search words into an array called needles. The array is going to be of size 6. And then we are going to load the puzzle lines into an array called haystack. This is going to be of size 8. We are going to need to sort our needles with arrays.sort. For each word in needles, we are going to search through our haystack using the array and string functions to see if these words are hidden somewhere in this haystack. When found, our message is going to say the word was found at row blank and column blank. So the row is going to be whichever of these the actual word is found on, and then the column is going to be whatever value it starts at. So if the word ferret starts here, it's going to be at column 1. If we have the word plum right here, it's going to start at 1, 2, 3, 4, 5. So at the 5th column here. Start coding this, we are going to go into our Eclipse, make a new Java project, press finish, do not create, expand this, go into src, make a new package, click finish, and then make a new class. This is going to be our main class. We're going to click public static void and finish. So now we have our class, which we're going to be working with. Now I'm going to grab the .dat file from this folder, and I'm going to click it and drag it down into the actual folder. I'm going to click copy to files, and it should be down here. And if we open it, we can see that we get the file right here. So the first thing that we want to do is make 2 different arrays. One array that holds all of these values and one array that holds all of these values. So knowing this, we will start making our arrays. Both of our arrays are going to be of type string, so we're going to have string brackets. We're going to have array needles, and this is equal to a new string, and we're going to have the length of our string. And actually, I'm just going to call this needles for simplicity. So we're going to have new string and the length of the string, which is 6. Since the assignment says that our array size is of 6, we're just going to hard code it to be 6. We're going to do the same thing for our haystack. So we're going to copy this, paste this here, except change the name to haystack, and we're going to change our size to 8. Again, because the instructions have it hard coded as 8. Now we need to try to read in our dat file. And now that we have both of these, we are going to surround it with a try-catch statement, like this. And if our file fails to open, we're just going to have a sysout that says file not found. And this is our try-catch. So now we're going to be in here, and we actually need to put these values into our arrays. For our needles, we are going to have a for loop. I'm going to do int a is equal to 0, and I'm going to run this until we hit the length of our needles, because that means we've gone through all 6 of these needles and added them in, and there's only 6 here. Then I'm going to have kind of a trash scanner that'll pick up these asterisks, and then we'll go on and feed these into the haystack array. So int a is equal to 0, and we're going to run this less than arrays needles.length. And then in here, we're going to do needles. We're going to have our brackets. We're going to have a is equal to scan.next. And this will get the next value and store it in the index with our needles. So that's how we would go for the needles. We want to sort our needles now, so we're going to do arrays.sort, and then inside of here, we are going to have our needles array. So we're going to just type in needles, and this should sort our needles. Now we're going to do the same thing, but we're not going to sort our haystack because we don't need to. So we're just going to have into haystack, and then here we are going to have our for loop. It's going to be kind of the same, so we can really just copy this header down here, and we're just going to change this to haystack.length, if I can spell that correctly. And then inside of our for loop, we are going to have haystack a is equal to scan.next. So this is going to be our for loop. What I did forget though is about these asterisks. So to get rid of the asterisks, because they are in our scanner, so the scan is going to pick it up as a string. Again, to get rid of this, we're just going to make a string and call this asterisk, and we're going to set it equal to scan.next. That way it gets those asterisks, stores it in here, doesn't do anything with it, but we have it if we were to use it. And so this is everything loaded up. This is our main method almost done. However, we have no way to say all of these things. We haven't found anything yet. But this is a lot of code to actually get this to work. So what we're going to do is make a method. We're going to call it searching, and we're going to make our method be traverse array. And in our traverse array, we want to see if our needles is in our haystack. So we're going to pass in needles, and we are also going to pass in haystack. So after we call this, it should print out all of these values, and we'll see if we need to do anything else in our main method. So we can create another method below this, public static void traverse array. We're not going to be returning anything, just printing out. We're going to have string needles and string haystack. These are the two arrays that are being passed in, and now we can start writing this. Well, we need a for loop to go through all of these needles. So this is going to be the for loop for our needles. Now we want to store the current value that's at the specific index that we're looking at, so we can see if it's in our haystack. That means we're going to have to make a string. We're going to call it current, and we'll set it equal to needles of index A, and A is going to be incremented every single time. That way we can see all of the needles. After we do this, we are going to want to check our haystack. So we're going to have a similar for loop for int A is equal to 0. We are going to run A the entire length of haystack. And I just realized that we can't reuse the same variable. Normally we could. That's only if we don't have a for loop encased inside of another for loop. Since it's inside of a for loop, we have to have a different variable name. So B has to be less than haystack dot length. And we're just going to have B++, that way it can eventually break out of this loop. So this is going to check inside of our haystack. Now I'm sure there's many different ways to do this. I'm going to use Boolean values to actually determine this. So in our for loop, we need to see if our current is inside of our hay temp. So you can think of this as true or false. If it's inside of our array, it is true, and if it is not in our array, it is false. So I'm going to make a local variable out here. It's going to be called contains. It'll be boolean contains, and I'm going to initialize it to false. Now in here, we're going to see if our haystack actually contains our needles. If not, it is just going to be false, and we are going to print out that something was not found. Because if it is not in our haystack array, it's going to stay false. That means nothing was found. So in here, we're going to say contains is equal to, and this is where we may or may not change contains depending on if it is in our haystack. Just like we did earlier, where we stored the current element in our array inside of this string, we're going to have to do that to our haystack to compare it. So just like this current up here, we're going to say string, and we're actually going to change this. I'm going to say this to current n for current needles, and then in this one I'm going to do current h for current haystack is equal to haystack, and then we're going to have our b value inside of here. Now contains is equal to current h dot contain, and this is a method of our string class, which is why we had to convert it to string. And we can see it'll return true if and only if the string contains the specific sequence of character values. So we have current h dot contains, and then inside of here we're going to pass our current n. So basically what we're saying is this string stores the elements at this index for our array. And then we're going to see if this element is inside of our haystack array. I spelled contains wrong, but after we fix that, this is what it is going to look like. Now we're going to have an if statement in here, which will break us out of our for loop if this is true, because if it's true, we found our value. We found the row and we have found the column. So if contains is equal to true, we're going to do a few things. The first is that we need to actually store the column. So I'm going to make a local variable up here. I'm going to call it column, so in column, and I'm going to initialize this to 0. and I'm also going to make our int row also equal to 0. So if contains is equal to true, we are going to set our column equal, and this is for our array index. Remember, because we stored all of our values here in our array. So we're going to be searching through here. Since we're finding the column, we are going to take the string that this is at, because if it is this string, and if we fall in here, that means this string is going to be this column. If the string is not in this column, in other words, if contains is equal to false, so it never hits here, we're just going to go through this for loop again, and we're going to keep going until we find something, or we just break out because the length has been reached and we haven't found anything. So column is equal to current h dot, and we have all of these different methods here. The one that we're going to use is index of. This is going to get the index of our current, and we're going to pass in current n. And passing in current n means that we are going to see where the first time this takes place in this string, and we're going to pass that index here. Now, indexes start at 0. Remember that. Indexes start at 0, and length, when we count length, we start at 1. So what we're going to do to make this user-friendly is add a 1 here. Again, because indexes start at 0 and lengths start at 1. So that is how that is going to look. Once we've found this, we don't need to go through our for loop anymore. So instead of wasting our computer power, we're just going to do break, and this will break out of the for loop. Once we've broken out of our for loop, we can print everything out because, you know, we've found everything. However, I did forget to use row, and this is going to be in our if statement too, because obviously if we found the column, we found the row. So row is just going to be equal to our b, because remember, every time this for loop iterates, we are going into the next row. So for loop goes through once, we're going in here. For loop goes through next time, we're going in here, and here, and here, and here. So every time the for loop goes through, we're going to be going through another iteration. However, remember, I said when we go through these things, the index is 0. We could see that it starts at 0 here. And when we read things as humans, we start at 1. So we're going to add 1 to this. So this will be our row, and this will be our column. We found both, so now we can just print them out. We are going to print them outside of this for loop, however, still inside of this for loop. If contains is equal to false, in other words, if we do not find anything, contains is set equal to false. So we never hit here, we go through the whole for loop, don't find anything, contains is false, we are going to print out that our word was not found. So this is going to be our system out.println. We're printing out the word, so we have this / so that we're able to print out a quotation mark, and then we have needles a, which will print out the element that we're currently looking at. Index a is going to be basically index 0, and when we look at our list, index 0 is computer, index 1 of needles is plum, index 2 of needles is copy, and so on and so forth. And we're basically saying that this element was not found. And this is only if contains is false. If it is true, that means we found something. So now we are going to have our else statement. Else, and then we're going to be in here. Again, we have a system.out.println. We are going to have the same thing at the beginning right here, except, surprise, surprise, we have found our value. So after we copy all of this part, and also this quotation part, so basically just copy the entire first part, we are not printing was not found. Instead, we are going to print the column and row it was found at. And we found the column and the row. So all we need to do is just add into our string that we're printing out, not storing, column at column. Oh, and it looks like the output wants us to do row and then column. So we're going to do at row, and then we're going to do a comma inside of here, and then we are going to have column, but we also need a period because we do like grammar here, and this should be our final code. Remember, this method was only to traverse our array to actually search for it, and it is part of our main method here. So if I run it, we can see the word chair at 8.1. Well, that does not tell us anything much. We are printing out row first, and I realize I just wrote row here and called it a day. we should have at row here, and then after this we're going to have at column, and now we can run this, and then also add a space here, and then also add a space here, and after all the spaces are correct, we get this output. We can check it with our dat file. If we look for a chair, it's going to be in this row. 1, 2, 3, 4, 5, 6, 7, 8. It looks to be in the 8th row in the first column, so that checks out. If we check it out for the rest of them, it works as well. So that means our code works. We found all of our words in the correct rows at their correct columns. So that's how you would go about writing this code. Pretty simple, but also pretty cool that we got to use booleans in here, and some mildly complex logic that was pretty fun to deal with. Again, remember that this is the main method, and this is the method that will actually search and see if our needle is in our haystack and then print it out. So 2 parts for this programming project.